In this problem, we are told to find the square roots of the complex number 21 minus 20i and write it in the form a plus bi. So a technique that I can use is, since it's saying that it wants the square roots, I'm going to take the square root of this complex number, and we're writing it in the form a plus bi, so I'm going to set it equal to a plus bi. So from here what I do is I want to square both sides to get rid of that square root on the left. So when I square this and square the right side, what I get is going to be 21 minus 20i on the left side, and on the right side I'm going to get a squared plus 2abi plus b squared I squared. And remember, I squared is equal to negative 1, so what I have is b squared times a negative 1, which is going to give me a negative b squared. Now what we're trying to do ultimately is to find what a and b are so that we can put it in the form a plus bi. So if I compare the two sides, notice the term with the I on the left side, this negative 20i, is going to be the same thing as the term with the right side, with the I on the right side, the 2abi. So those correspond, and then the other part, the number part, 21, is going to correspond with the number part on the right side, which is a squared minus b squared. So 21 is going to equal a squared minus b squared, and negative 20 is going to equal 2 times a times b. So let me simplify the right side a little bit by dividing both sides by 2. So I'm going to get negative 10 is equal to a times b. So remember, my goal is to find ultimately what a and b are. So if a times b is negative 10, well then a could either be negative 5 and b could be a positive 2, or a could be positive 5 and b could be negative 2. Or let's try this, we can try either 10 times negative 1, or it could be negative 10 and positive 1. Now I can automatically eliminate 10 and negative 1 and negative 10 and 1, because if I try to plug them back into here, this 21 equals a squared plus b squared. If a is 10, I'm going to get 10 squared, which is 100, minus 1 squared, which is 1. So 100 minus 1 would be 99. However, it needs to be 21. If I tried it with negative 10 and positive 1, that would not work either. If I tried maybe switching it around where I guess a could be negative 1 and b could be 10, either way it's not going to work. I'm going to get 1 minus 100, which would make it just a negative 99 instead. So I can eliminate these two. So I'm stuck with negative 5 and positive 2. We'll check that one quickly. Negative 5, if I plug that into a, I'm going to get negative 5 squared, which is 25, minus 2 squared, which is 4. So 25 minus 4 is 21. So that would work. And same with if a is 5 and b is negative 2, that would work as well. So we found a and b, the two possibilities that they could be. So I plugged them into this correct form, a plus bi. So I'm going to get as my final answer is going to be negative 5 plus 2i. Or we said a could be a positive 5 and b could be a negative 2. So I get 5 minus 2i. So those are your two answers, and we are done.